All right, purpose of this video is going to be to give a demonstration on common applications of multiplying polynomials. For this particular video, I'm going to focus on areas of rectangles and finding shaded areas between rectangles. Some other couple of applications, though, are going to be like triangles and trapezoids. So I put their formulas on here in case that was you. Basically, the concept is going to be the same. It's just a matter of applying the correct formula. So for this problem, what we're going to do in this video is we're going to focus mainly on rectangles, finding area, and finding a shaded region between two rectangles. So let's go ahead and let's get at it. So getting started on it, here we go. So the first example is just going to be to determine the area and the perimeter of the following object. So essentially what this is going to test is going to test two things. It's going to test, do you know how to multiply polynomials? And it's going to test also, do you know how to add polynomials? So when you multiply and you add polynomials, they're done a little bit differently. But those are the two skills. So first things first we'll calculate is the area. And really it's because the area inevitably is going to be, in my mind, a little bit less work than finding the perimeter. Now, the area of a rectangle. So you do need to know that the area of a rectangle is you take its length. So you take its length, all right, and you multiply it by its width. So length times width. So in this case, all right, I have my length labeled as 3x plus 1, and I have my width labeled as 2x. Now, this is a binomial. It has two terms, and this is a monomial. So in this problem, I'm going to use the commutative property, and as opposed to doing length times width, the commutative property allows me to switch that. So what I'm going to do is the width and multiply it by the length because it's a little bit easier of a setup. So let's go ahead and do that. So the area of this is going to be equal to A equals, so the width, which is 2x, and I'm going to multiply that by 3x plus 1. And now from here, from here, all it's really asking me to do is it's asking me to just go ahead and multiply it out. So you don't want to leave it like this. Most instructions that you'll be asked will ask you to simplify the expression. And to simplify the expressions, it simply means to go ahead and do that distributive property. So in this case, we'll go ahead and do that. So A equals, so I will take 2x and multiply it by 3x. Now you do need to remember when you were doing practicing skills, you do need to know that when you have variables that they follow the product rule. So x times x, the x and the x, you will add the exponents, and the 2 and the 3, you will multiply them. So 2 times 3 is not 5. Okay, it is 6. So the coefficients will follow multiplication, but the variables will follow addition. So 1 and 1 makes 2. All right, and now it's the distributive property. So you don't just get to multiply the x's together, you also now have to multiply the 2x by the positive 1. So what you get there is 2x times 1, anything multiplied by itself, by 1 is itself, sorry, so you get 2x. And there you have it, you're done. And the reason you can't do anymore is because these last two terms that you've created are unlike terms. And then that's it, that's what it means to be simplified. Okay, so there's your expression. When you multiply polynomials, they make a new polynomial. So your answer will be in polynomial form. All right, and the next thing we'll talk about is perimeter. Now the perimeter is just the sum of the exteriors. So what you need to remember though, is that nobody's going to label pretty much every side of a rectangle. So what you need to know is that every rectangle has two sides that are the length, and it has two sides that are the width. So when you go ahead and add this, it's going to be 2x, okay, plus 2x, and then plus, then you have 3x plus 1, okay, and then an addition of another 3x plus 1. Now, a lot of people may or may not write this out. There's a formula like this, but I think most students do better when they just write it all out as trying to remember the formula. I don't necessarily know how many of them remember the formula, but if you wanted to, the formula for this is perimeter of a rectangle is 2 times the length plus 2 times the width. And what you see there is I just have it written out in long form. So you'll get the same answer. But either way, here we go. So remember, when adding, the deal is you can only add like terms. So what I'm going to search for is I'm going to search for variables that are the same letter and have the same exponent. So what I've got is I used the wrong pencil there. So I got an x, right? They match. I got another x, they match. And I got another x, they match. So inevitably what I can now just simply do is I can take all of their coefficients, So the 2, and the 3, and I can add them all up. So 2 plus 2 is 4, 3 plus 3 is 6, and 4 and 6 makes 10. So inevitably what I have is I've got 10 x's. Now notice in this problem, I didn't do anything with the exponent. All right, when you add monomials together, you don't get to do anything with their exponent. It just is how many of that monomial do you have. So the last thing I have to take a look for is if there's any other like terms, and in this case I do. I've got this plus 1 and this plus 1 here, and 1 plus 1 makes 2. And there you have it. So there's the idea of area and perimeter. They're the most common. So let's go on to the next one that deals with this idea of a shaded region, because that sometimes seems to be a stickler for most people. All right, so let's take a look at this example of determining the area of the shaded region. So notice where this shaded region is here. It's this gray area. It's in between, okay, the large rectangle and the small rectangle. So inevitably what you need to understand is when you take the area of a rectangle, okay, it's not like you're just taking the area of part of the interior. You're taking the part of the entire interior. So to show you this really quick, okay, if you find the area of just the outside, what you will calculate is the area of everything in here. Now notice what I'm doing, okay? I'm crossing over that entire non-shaded part as well. So it's like when you find the area of something, you have to understand that you're finding the area of everything on its inside, whether you want it to be there or not, okay? So the question is then, well, how do I account for that blank area? Well, that blank area, if you think of it, okay, it's kind of like a hole, right? So it's kind of like if you threw a ball through a window, all right, it's going to end up on the other side somewhere down here. So this area is a hole, all right? So, I spelled hole wrong, math teacher, man. Okay, so it's a hole. And holes in mathematics, okay, are created by cutting space out. And how do you cut space out? You cut space out by subtracting, all right? So what we're going to do here is we're going to take the area, okay, of this entire large exterior rectangle, and then what we're going to do is we're going to cut out the smaller rectangle. Now the nice thing is that the smaller rectangle already comes with dimensions on it, and there's a reason for that, so that it allows me to calculate the area of just this part. And what I can do is I can subtract this from the larger. So if I was writing up a formula for this right now, I would say the area of the shaded region is going to be the area of the large rectangle minus the area of the small rectangle, okay? So what I'm going to do at this point is I'm going to calculate the large rectangle and the small rectangle independent of one another. And then what I'm going to do is I'm going to write up a subtraction problem. So here we go. So let's find the area of the large rectangle. So I'll just use area L. So the large rectangle is a binomial times a binomial. So I'll just write this out as x plus 7, and you gotta put it in parentheses when you do this, times 4x minus 5. And the reason you have to put it in parentheses is because polynomials are groups of expressions. So you're taking a group, multiplying it by another group. So we use parentheses in mathematics to show that. So now what I do is I have to follow the rules of a binomial times a binomial. So now I have this idea of this double distribution, or some people like to call it FOIL. So what I'll do is I'll take the first term and multiply it by both terms in the second group. So x times 4x is 4x squared, and x times negative 5 is negative 5x. And then I will take the 7, multiply it by the 4x, and then I will take the 7 and multiply it by the negative 5. And then I'll simplify that expression. So 7 times 4x is positive 28x, and 7 times negative 5 is negative 35. And now what I'll do is I'll go ahead and I'll simplify this expression, because I do have some like terms here of the x and the x, which creates 4x squared, all right, plus 23x minus 35. Now notice when I simplify this, okay, that I don't change the exponents on these two like terms, okay? They're the same ones. They're ones, so they remain ones, okay? You just have to get in the habit of doing that, because I know we just did a problem where we changed the exponents, but you only get to change exponents when you multiply. All right, so that's the area of the larger one. And then I will take the area of the smaller one, all right? So the area of the smaller one is found by doing this group of x plus 2 and multiplying that by 2x plus 1. So now we go through and we do this work. So x times 2x, x times 1. So I get 2x squared, okay, plus x. and then I take the 2 and multiply it by each term, which gets me 2 times 2x, which is positive 4x, and 2 times 1, which is positive 2. So the area of the small rectangle is going to be this 2x squared plus, now notice I have two like terms of a 4 and a 1, which gives me a 5x plus 2. Now, I did all that work, but yet I'm not done, because what I now have to do is I have to subtract them. So now what you need to remember is polynomials are groups of expressions. So when I do this particular problem, okay, I'm going to move this over a little bit, okay, so I have some space to write. All right, when I do this particular problem, when you have groups, you must subtract the groups. So the area of the shaded region is going to be equivalent to the group of the first polynomial, which is 4x squared plus 23x minus 35, okay? And then I'm going to give myself a little room here, so I'm going to go ahead and move this over, all right? And then it's going to be minus the group of 2x squared plus 5x plus 2. Now, the reason this becomes important that you understand that the polynomials as themselves are groups is because when I put a subtraction sign in front of a group, it's actually a -1. And what a lot of people mix up here is they only write minus this 2x squared, and they don't put groups around it, and then they get the whole expression wrong. So it's imperative that you think of polynomials as groups. So the area of the shaded region, okay, so shaded here, SH, is equal to, all right, when you do the subtraction one, you must distribute this -1 like we talked about in my videos before when you're adding or subtracting polynomials. So we get this 4x squared, so now we can drop the parentheses on this one. So 4x squared plus 23x minus 35. And then -1 times 2x squared is -2x squared. And -1 times positive 5 is -5x. And -1 times 2 is -2. So now from here, it's just a matter of cleaning it up, and then we will finally be done. So the area of the shaded region, okay, is equivalent to, so 4x squared minus 2x squared is 2x squared. 23x minus 5x is positive 18x, and -35 minus 2 is equivalent to -37. And then this will be your final answer. So what's important here to remember is that you must be thinking of polynomials when you find areas of them as groups. So I hope this helps with whatever you're doing, and let me know.